Welcome. In this video, we'll show how CloudCalc can interface with some other popular pipe stress programs. In this case, it would be Caesar 2, but it can interface, obviously, with anything that can import or export a C2 neutral file. So let's go over to Caesar 2 and take a look at a model that was built there. This is one called Test Job. It's consists of a number of things. We've got pipes, valves, restraints. Here we have a uniform load. We have a concentrated, or we have two different uniform loads, vector 1 and vector 2. We have a concentrated force and moment. This uniform load is applied here, and as we see, it is turned off, deactivated 2 elements down. It's got a few plus Y restraints with friction applied. We've got displacements at node 5, and then at node 6000, which happens to be a C node or a connected node to this WRC 297 nozzle. And likewise, we have a spring hanger applied here, anvil, spring hanger table, 25% load variation, freeing the restraint at node 5. So we see this is a model that uses a lot of the features of Caesar 2. So on occasion, you may, if you're using CloudCalc's pipe stress, you may get a model that was, you may have to work with another organization that uses Caesar 2, or you may have to deliver your pipe stress model in a Caesar 2 format. So we'll look at how to do that here. And the way to do that is you create a, it's been changed, do I want to save it? Sure. You create a Caesar 2 neutral file. So we would go to Interfaces, Caesar 2 neutral file, and we want to convert a Caesar 2 input file to a neutral file. And this one, we pick the file, it's called Test Job. Pick that. Convert it, goes to test job 1 dash, it's called test job 1, goes to test job 1.cii, and we want to convert that, which it did. Okay, so now we want to go into CloudCalc, and we'll say Tools, Interfaces, Caesar 2 Import, and we'll go and we'll pick this. Okay, the current model will be overwritten by this import, so what we want to do is start a new one. So we'll say New, and we'll call this Tutor1, Tutor-1. Say OK, and we'll say Tools, Interfaces, Caesar 2 Import. Choose our file, and it's in Caesar 2 Files, testjob1.cii, which is what we just created. And we can now import this. And the import process will go through and find anything that has to notify you about anything that couldn't quite bring over, or anything that is a little different, or any assumptions it made. For example, it tells you that the Caesar 2 neutral file does not include load cases, so those will obviously not come over, and you will have to set those up in the corresponding manner here in CloudCalc. Tells you the version of the neutral files bringing over, mentions that the allowable stress data, which may have been hard entered in Caesar 2, is all based upon our online database. So that allowable stress data did not come over, but rather will be pulled from our database. Caesar 2 load cycles, for example, are put in as a function of the material, but rather in CloudCalc they have to be put in as a function of the load cases, which makes is logical, etc. It also tells you it did not support nozzles. In that case, the nozzle at node 40, and remember it had a C node at 6000, will be replaced by an anchor here. So it just goes through, tells you some things that you ought to take note of. If it didn't come across, it'll tell you there was an error on such and such a line, etc., and you can go in and fix that file. So if we say OK, we now see that it came across, and we can check and see we have a spring hanger here. Obviously, if we look at the spring hanger, it was anvil type, etc. The default load variation 25, release node at 5, exactly what we should expect. If we want to look at our restraint here. We have a restraint at the first bend node is plus y. It's got a friction factor of 0.3, etc. If we take a look here, we see the same thing. It's a plus y with a friction factor of 0.3. Now, this is where one difference was. Caesar 2 had a WRC 297 nozzle, which is basically a restraint in 6 degrees of freedom. And if we look here, we also have, we've converted it to an anchor at the 2 node with a C node of 6,000. Why is there a C node at 6,000, or what happens there? If we go and look at our piping loads applied displacements, we have a displacement both at node 5 and at 6,000 as expected. Let's take a look at whether all these load cases came over. The other thing, the T's, the valves, etc., come over. We can take a look at the load cases. We can look at our plot our concentrated loads, which we do. We've got a load of 1,000 minus 1,000 in the y direction, which was concentrated case 1. And we can look at uniform loads. We have 2 uniform loads, uniform 1 and 2, as we had in Caesar 2. If we look at that, this was in the x direction, the uniform load in the x direction, just on these 2 elements. And uniform load here, y direction, minus 10 on these 2 as well. So we see that all the data came over. The only thing that didn't come over was this WRC 297 nozzle came over as an anchor. And if we plot displacements here, you see that we've got the 2 in the locations where they were applied at node 5 and at node 6,000 here. So all of the data came across pretty much. We now have to go in and set up our static load cases. So if we come here, it defaulted to a single load case of self-weight only, which is a pipe and the insulation, if any. Let's see if we have any here. Insulation 3 inches at 0.006 pounds per cubic inch, etc. Corrosion. All this information came over, pipe size, etc. So if we want to set up our static load cases, come here, hit our initialize load cases, and it comes up with because there are spring hangers that need to be designed, it comes up with a restrained weight, a free thermal case, and once we've picked out the springs, we have operating cases, which has 2 temperatures. Oh, I forgot to mention that. Let's look at the 2 temperatures. Temperature 1 is 600 degrees, the entire thing. Temperature 2, 400 degrees, the entire thing, entire system. And if we go back here, we'll see 2 operating cases, sustained case, 2 sustained cases with different pressures, etc., 2 occasional cases to reflect the 2 uniform loads and all of the various expansion cases. So if you run this analysis, you get your results, and we can go through and step through the results. Everything seems to pass so far. We get a failure down at this point, and that would be for our one of our sustained cases, etc. And you can do all of your redesign here, and at some point you may decide that you have to send it back out to, you may redesign your system, decide that you have to send it back out to Caesar 2. And let's go through that process. We can do that as well. Let me turn off these loads, for example. Uniform, okay, concentrated off, uniform off, etc. And at this point, we may want to make a change. Turn off my displacements and redraw here. Okay, I may want to do a change. So I can do a node select, press the hotkey N or grab this. I may want to put a branch off in this direction. If I go into quick design or quick quick design mode. Maybe I'll go minus 120 inches in the Z direction and minus 4.25. And then I'll select this and make it a flange, for example. And 50 pounds, rigid element, flange, and maybe to go into X mode. Zoom in, put a spring at this location, 52 hangers, and I'll go with an anvil, etc. Spring hanger here. Okay, at this point I may have made the changes that I wish, and I may want to send that back to Caesar 2 because I may be dealing with a client or a consultant who's using Caesar 2. Is there pipe stress analysis? We can go back, Tools, Interfaces, Caesar 2 Export, at which point I send it back. It goes to a CII file, and now I can go to Caesar 2 neutral file and say I want to convert a Caesar 2 neutral file to an input file. And this was down in downloads and tutor 1.cii. I go and I do my conversion. It came across, tell you if there were any errors. I can now open, and it was in downloads. And there we go. The only difference here is you may, once you get back here, is you might want to change this back to a WRC 297 nozzle, but everything else should be intact. There's your concentrated load, there's your new spring, there's the new elements that you put in, the flange, etc. And that's it. As easy as that. Pass it back and forth as you see fit. And have fun with that. And thank you for your efforts in helping with the beta. Thanks.